All right, goals for today. We're going to talk about segment lengths. We're going to use this idea of the segment addition postulate. We're going to talk about this idea of between. We're going to start out with an example right away where it's a dictation exercise. And then we have to talk about this idea of congruent. Okay, big fancy word. Okay, but not that hard. All right, so right off the bat, it talks about line segment and betweenness. So what I want you to do is just follow the instructions and see if you can come up with the picture that I have in mind. Okay? Draw line segment AB. So right under where it says line segment and betweenness, draw line segment AB. Put point C between A and B. Point C between A and B. Put point D between C and B. All right, so did you end up with something that looks roughly like this? All right, so you understand what the idea of between is. All right, not too bad. All right, so what are we going to do with this? Essentially, we're talking about line segments, their lengths, congruent segments, so on and so forth. Okay, so I'm going to give you another set of instructions. I am going to tell you that AB, the length of A to B is equal to, say, 20 inches. I am going to tell you that the length of segment CD is equal to the length of segment DB. I am going to tell you that the length of segment AC is equal to 8 inches. I want to know, how long is CD? Can you do that? See what we got? Lynette, you got a fourth? Ross?
6.
6?
6.
6? And in the back? 6. Okay? Now, you're saying that it's a fourth of the entire thing?
Yeah.
Is that what you mean? Okay, but I want the actual length. Like, how long is it? 2 inches, 6 inches, 12 inches, 8 inches? Probably you're going to go with what everybody else is saying. Okay. Can anybody explain how they got the 6 inches? All right, go ahead, Spencer.
Because A to C is 8 inches and CD is equal to DB, we just,
What is the length from C to B if the whole thing we said was 20?
12 inches.
All right, so if from C to B is 12 and they're equal, then what do you do?
Divide by 2.
Divide by 2. Okay, and essentially that's the concept. Okay, all right. So little thing that I want you to be aware of is I did this little tick mark, tick, tick. Basically, I am saying that this length is equal to this length when I do those little tick marks. Okay, that's going to be congruent. We'll talk about congruent later, but I just want to give you a heads up on that. Anytime you see tick, tick, that means congruent. Okay? All right. So we got something known as the segment addition postulate. I gave you a couple postulates yesterday. Okay, the first one, it said between any 2 points there exists a
Line segment.
line. Well, we said line, not line segment, but you're on the right track. Between any 3 points there exists a
Plane.
very good. Okay, so now we've got a new one. The segment addition postulate basically says that if 3 points A, B, and C are collinear, and we have B is between A and C, then we have the following picture. Okay, so A, B, C, that AB plus BC equals the whole thing AC. Would you agree with that?
Yeah.
So if we threw in some examples, if AB was 4 and BC is equal to 5, what's the length of the whole thing, AC?
9.
9. Okay, that's the segment addition postulate. The whole is equal to the sum of the parts. Okay, not too bad. Okay, all right, so we're going to use that idea, but but we're going to step it up a degree. We're going to go back and use the concept of algebra. We're actually going to start with example 2 and then we'll go back to example 1. All right? So in this one, example 2, it tells us that AB is equal to 25. The whole thing is 25. Okay? It says from A to N is 2x minus 6 and N to B is x plus 7. Find the value of x. Ideas. We need an equation. Can anybody create an equation so that we can solve for x? Anybody? Anybody? Go ahead.
2x minus 6 equals x plus 7.
Okay, so she says 2x minus 6 equals x plus 7. So AN is equal to NB. It says that somewhere in the directions. Are they equal in length? Do they have to be equal in length
No.
to add up to be 25?
No.
No, one of them could be, say, like 10, and one of them could be 15. One of them could be 8, and one could be 17, right? So are they equal in length? Can we use the equation that she came up with?
Yes.
Okay, but then if you say yes,
No.
are we using the 25?
No.
No. So ideas. She's on the right track. We need to tweak it a little bit. Well, like our example above, so if I go back to up here, we had 8 plus 12 equaled 20. So the segment on the left plus the segment on the right added to be 20. 8 plus 12 equals 20. So can't we use that concept down here and say, instead of them, you know, being equal to each other, okay, if all of this is 25, can I do 2x minus 6 plus x plus 7? The sum of the two segments equals 25. Does that make sense?
Yeah.
Okay, so solve for x. Some of you, sorry I had a plus here, it should have been a minus. Are you getting a 3x plus 1 equal to 25? Subtracting the 1 over, getting 3x equal to 24, dividing by 3 and getting x equal to 8. Are we good? All right, so now we have to answer the question. The question says, what's the length of A to N? What's the length of AN? Summer.
10.
10. Okay, if AN is 10, that means if I plug in the 8 for the x and add 7, I should get 15, and that 10 plus 15 is 25. Is that correct?
Yes.
All right. So a lot of times what we do with the geometry is we have you plug it back into the angles, plug it back into the segments, so that you can use that as your check. Okay, and now you can see, oh, the sum of these two lengths do add up to be 25, which means it must be right. Because let's just say that you kept with the mistake of what I had, and I did, you know, plus here, and I had 13, subtracted 13, and got 12 divided by 3, and I got an x equal to 4, okay, which we know is wrong, okay? But you go and plug 4 back in, you would have gotten a segment length of 2, and 4 plus 7 is 11. Is 2 plus 11 equal to 25? No. So if the two segments don't equal the number that they want, then that tells you that probably your variable's wrong, okay? So just FYI, all right? All right, so now we're going over to example number 1. Big hint, and this is for all of geometry, not just today. If they don't give you a picture, draw a picture. Because a picture's worth 1,000 words, it might be a little bit easier. Okay? So, see if you can draw the picture, create an equation, solve for x. So, big thing, you know, once you guys do eventually solve, make sure you go back and answer the question, what's the length of RS and ST? Those two values should add up to be 60. Okay, so a lot of you are getting x equal to 12. Okay, now we got to plug it back in. What's 3 times 12 minus 16? What's RS equal to? Anybody get it? 20. Okay. So what's 4 times 12 minus 8? What's ST equal to?
40.
40. Is 20 plus 40 equal to 60?
Yes.
Yes. So that's a good indication that we did it right. Okay? So that's the nice thing. Questions? All right, so now we go down to the concept of congruence, which I mentioned a little bit earlier. And you see two things here. Okay? In layman's terms, congruent simply means equal to. Okay? So we're going to talk about the idea of, you know, triangles being congruent, angles being congruent, segments being congruent, and, you know, and that's what we're doing right now. Okay? Essentially, it's equal to, the symbol for congruence is the equal to sign with this little tilde above it. And you see it over here with the AB is congruent to CD. Okay? All right, couple things that you do have to understand though. Sometimes we want the equal to. Anytime that we are computing, okay, we are solving, we are finding the measure of, that's when you use equal to. So like up here, we said ST equals 40. Okay? Anytime we're, you know, giving a measure of, we're going to use the equal sign. All right? The congruence we do when we want to compare. Okay? So for example, Lynette, you the same height as anybody else in class? Do you know of anybody? No? How tall are you?
5'1".
5'1". Any 5'1"s?
Oh, me.
You're 5'1". Okay. Colin, right?
I'm not 5'1".
Okay. But you're 5'1" today.
Okay.
Okay? All right. So I would say that she equals 5 feet 1 inch tall. I'm using a number. But I would say, if I wanted to compare, that they are congruent in height because they are both 5'1". So I would say that is congruent in height to Colin. Okay? So that's the idea. Okay? Does that make sense? So if I'm comparing things, I use the congruent statement. If I'm giving a measure of something, then I use the equal statement. Okay? And then I talked about this earlier already. If you need it, you know, if I had, say, segment AB over here, okay, and then I had segment CD over here, tick, tick. That's the way that we symbolize that things are congruent. Okay? And eventually we're going to do it with angles. Like this angle is congruent to this angle. We're going to do tick, tick. We're going to put these little tick marks inside. Okay? But we'll get to that later on as well. Okay? All right, so just checking to see if you understand the concept of congruent. It asks you to find two segments that are congruent from this number line. If you can do that, write it as a statement like you see above with AB congruent to CD. See if you can do that. All right, so you said XY is congruent in length to ZW. What do you guys think? All right, so now, this would be your congruent statement. If he wanted to say what the value of XY was, how long is XY? How many units?
Oh, 4.
4. So XY is 4 units in length. Okay, so then we would use the equal to sign. Okay? All right. Simple question. Again, just checking for understanding. Something a little bit different here. Using the concept of the segment addition postulate. Can someone tell me what the value of WX is? And how you're going to get it? What's the length from W to X? Colin? 107. How'd you get it?
I subtracted 37 from 144.
Sounds good. Okay. Essentially, he's using the segment addition postulate. Okay, just in a different way. 37 plus X equals 144, and then solving by subtracting. Okay. All right. Last one. If we're good and we understand the concepts, okay, It wants you to graph the points, connect R to S for segment RS, connect T to U for segment TU, and determine whether or not they're congruent in length. Them, you should have ended up with RS equal to a 4 and TU equal to 4. So we could say RS equals 4. We could say that TU equals 4, just to emphasize the difference between equals and congruent. But then we would say that RS is congruent to TU. And we would use the bars and we would use that little tilde thing, okay? So again, just understand, it's a minor little thing, but we're going to use congruent a lot, okay? All right, just checking for understanding. Do we understand the concept of a point being between two other points? You good with between? Do you understand the idea of congruent? If you were given this question here, would you be able to solve for x? Do we need to do this one? No? Okay, then we'll use it maybe as a warm-up tomorrow. Okay, and then same concept, just without a picture. You'd be able to draw a picture and then solve for x. You good? All right. So then